Good morning, guys, and welcome to the yet another lecture of simulation of business system. So now, having seen the basic assumptions and fundamentals that we require to start the simulation model, we are now going to do the simple example of the simulation model. Before we doing that, there is also one more thing that I need you guys to understand, which is called as the table of random digits. And as I said earlier, that we generate IID random variates, and as mentioned, IID stands for independent and identically distributed. Random variates. And why do we generate random variates? To model uncertainty or the probabilistic behavior of the system. Or the randomness of the system. Okay. So, here either we are trying to model the uncertainty or the probabilistic behavior of the system or the randomness of the system. All of them means pretty much the same. Okay. So, one way to do it is we basically, one of the most common option to take it is you take a uniform 0 1 random variates, which means the values will be always between 0 and 1 and all values are equally likely. That means minimum equal to 0, maximum equal to 1, all values in between are equally likely. Okay. Or in a way to draw this will be, if you say this is 0 and this is 1, so then the graph of this will be something like this. So every value in between this will have the same probability of occurrence. Okay. And then scale to whatever you want to do. Okay. Other option is that for doing this you require some form of random numbers from some place. So there is a table of random digits, and in which you can take random digits and then use that as a way to do it. So most of the time what I do is I take this table of random digits and I say, if I say that the time between arrivals, say for example, time between arrivals, which is also the inter-arrival time, times are uniformly distributed between 5 and 15 minutes. So multiplication becomes easy, minutes. If I say that, then what do I do is I use these digits as sampling the uniform 0 1. So let us say I am going to take 2-digit accuracy. So I will just take the first 2-digit value and the first arrival time, okay, A1 will be equal to, the value will be 0.19, it will be 5 plus 0.19 times 15 minus 5, or the equation is arrival time AI is equal to min plus random value multiplied by maximum minus minimum value. So 5 is the minimum value, okay, and then the random value is 0.19 that I got from here, 2-digit accuracy. If I take 3-digit, it will be 0.192, and this is the max and this is the min. So this will be 5 plus 0.19 multiplied by 10. So it will be 5 plus 1.9, which will be equal to 6.9. So, the first arrival time will be 6.9 minutes, seconds, whatever you want to call it. Let me put it as minute. Then if I have to calculate A2 will be these next value, next two digits, 5 plus 0.22, 15 minus 5. So, this will be 5 plus 2.2, this will be 7.2, like this. Then the next digit will be 3 and 9, 39. Okay. So, 0.39. So, we keep on doing this. So, this is a process in which your random digits can be used to generate your arrival times. Same is true for the service times. So, in the next model that I am going to demonstrate to you guys, we will be following this approach. Okay. This approach to calculate the arrival times, service times and other things. But I will not be taking this random value for the time being, you will be just taking numbers, randomly picking up numbers. So, that you can see how the mechanism works, but these numbers can be derived using this process, which will actually model randomness. The reason why we are doing this is, instead of taking all values exactly the same, we are basically saying is, in this particular case is that all values of between 5 and 15 minutes are possible for each consecutive arrivals. If the one person is arriving at after the 6th minute, the next person can arrive any time between 5 to 15 minutes after that. So, then if the next person arrives in 10 minutes, then that means 6 plus 10, which will be 16th minute is the next person will be arriving, and that is how the simulation clock will advance. I hope this makes sense. So, let us try to do a simple hand simulation of our single server model. So, the first I will do is a diagram which is typically called as a system diagram. We call this as the S1 or the single server. Okay. And here is a person who is waiting there to get serviced, and let us assume that the service times are uniformly distributed between 5 and 10 minutes. So, that means if anybody comes in, the service time can take any value. This implies any value between 5 and 10 are possible with same probability. So, if I draw the graph of this, it will be like this. Okay. Here will be your time and this will be your probability, okay, and 0, then you have 5, then you have 10, then you have 15, like this. So, up to 5 there is no probability, at 5 it jumps up to one value, and then up to 10 remains the same and it comes down. So, all values between 5 and 10, everything here is equally likely, same probability of occurrence. Okay. Then people come in and there is a queue also in the system. When an arrival happens, okay, a person arriving into the system, okay, an arrival, this is an arrival, let us say. Arrival has two things that it can do. One is server busy? Is server free? These two questions the arrival has to answer. If the server is free, it will go directly get served. If the server is busy, it will come and stay in the queue. Okay. So, let's say that the arrival times are uniformly distributed. We will take uniformly distributed for the time being to make life easy, and then we will see complicated models later. Arrival times are uniformly distributed between 5 and 15 minutes. Okay. So, if I draw the graph of this, arrival times will be something like this, 0, 5, 10, 15, 20, the time goes like this, and here you have the probability associated with it. So, up to 5 the probability is a 0, and at 5 it goes up, and then it comes down like this up to, with all values here are equally likely. Okay. So, this is what the this is called as the PDF, probability density function, the PDF of the arrival and service time distributions, and this is a queue of the server. It is FIFO, first in first out, and has infinite capacity. Any number of people can, this means infinite capacity means any number of people can wait in the queue. Okay. That is what we talk about, the infinite capacity queue. With this, now what we will try to do is we will try to simulate people arriving into the system. So, the logic is customers arrive, then if server is free, go get served. If server is busy, wait in queue. Then once service is done, leave the system. Okay. And so, the customer is your entity. Okay. So, the attributes of the entity includes, the attributes of the entity includes arrival time in the system, okay, time at which service will start, time at which service will end, time at which entity leaves the system. Okay. So, these are the attributes of the model that we are talking about. So, we take at this point as the customer as the entity. If you look at the server logic, if no one is waiting in the queue, then do nothing. Queue and no one at desk. If there is nobody waiting in the queue and there is no one at the desk, then do nothing or remain idle. Other option is, if number in the queue is not 0, call the next person according to FIFO discipline and continue service. So, the logic of the server who is doing the service is pretty much like this. If no one is waiting in the queue and no one is left at the desk, then do nothing, remain idle. If someone is waiting in the queue length is not 0, then call the next person according to the FIFO discipline and then continue the service. Okay. And at the end of the day, we are trying to find average time in the system and find percentage of time server is busy. Okay. So, these are the two questions that we are interested in answering at this particular simulation. I hope all of you understand the example setup that we have, and also remember when we draw a diagram like this, okay, with the queue, then the server and other things, this diagram is also called as the system diagram. It is different from the system diagram that is drawn in the systems engineering, but in this is more of a simulation system diagram. So, I hope everybody understands this example setup, and using this example setup we are going to do the simulation. So, as I said earlier, arrival is uniform 5 and 15, service is uniform 5 and 10, and Q is 5 4, first in first out. Okay. So, I am doing a system diagram once again, so that you have an idea. Server waiting here S1, and here is the queue, it is a 5 4 queue, okay, and arrivals is going to happen here. So, we first make a table or a tabular format, remember, and this is called as the entity list or event list. Okay, let us think about it as an entity list for the time being, and then we can say it as customer number, then we will call it as arrival time, okay, then service start, service end, depart, okay. All right. So, now we also told that arrival happens after some time or not at t equal to 0. So, the system began, a time is ticking, okay, time is going on. So, first the arrival time is between 5 and 15. So, I am taking a random value, I take the first random value as 8. Okay. So, the customer 1 arrives at 8th minute. Okay. So, the customer 1 arrives, C1, okay. He comes and he checks what happens. Is the server idle? Yes, server is idle. So, he goes straight to the server. Okay. So, the service can start at 8. Okay. I will write my comments here, so it is easy for you to follow. Server idle, service begin immediately. Okay. And now the service time, when will the service end? You have to sample a time between the 5 and 10, uniform between 5 and 10. So, let us say I take it as 6 time units. Okay. So, the service starts at 8, then 6 it will take 6 minutes to complete the service. So, it will be over at the 14th minute, okay, and that is the idea. Okay. So, up to from 8 to 14 the service will at 14 time unit the service will end, and at the entity will also depart exactly at 14. Okay. And one arrival has already happened, you have to schedule the arrival of the next, because as I said it is a next event. So, every time you do one event you have to also schedule the next event. So, in this case our entity is the customer. So, you schedule the next event, which is the next arrival, and again for that you sample a time between this, and let us say you got the value as 7 units. Okay. So, that 7 means the next arrival happens at 15, okay, 8 plus 2 15, right. Entity will arrive, and at 15 when it will arrive, this is your C2. When it arrives, it actually sees that is a server idle. At 14 the time the entity has finished the service and it has left, C1 has left. So, the server is idle, service begin immediately. Okay. So, the service will start at 15 and service, I am taking the service time to be, let us say as 10 time units. So, it will get over at 25. I am putting it as 10 because any value between 5 and 10 is equally possible, and it will leave at 25. So, now I am doing the next event of this, and I sampled a value, okay, and I got the time as, I took the arrival time as 5. Okay. So, so then 15 plus 5, the arrival will happen at 20. When it comes at 20, this is your C3. Okay. When it comes at 20, it sees that the server is not free, it is busy. So, what it does is the C3 will come and join the queue. Okay. So, it will wait, and when can the service begin? It can begin only at 25 time units, because as soon as the server is finished, server will look and see whether there is anybody in the queue, sees that there is one person in the queue, it will immediately pull that person and start the service. So, service will start at 25, and let us take sample another value of the service time, and let us take it as 9 units. So, excuse me. So, the 9 units, the service will end at 34 a minute, okay, and this guy will depart at exactly at 34. And then this arrival that happened at 20, what will happen is you have to also to schedule the next arrival, which is the fourth entity. Let us say we sample a time of 6, let us say randomly we sample a time of 6. So, this entity arrives at 26th time unit, and this is your C4, customer 4, and when he comes in, he finds that no, the entity is being served by the system. Okay. So, what it will do is, it will wait and the service can start only at 34, and we will, how long it will be, we will sample little later. Now that it is waiting in the queue, this arrival will also trigger the next arrival, okay, at the 26th. Okay. So, now let us say we take the next time I got it as 7 time units. So, with the 7 time unit, the fifth entity has arrived in the system. So, here is your fifth entity C5, and so 26 plus 7, that will be 33. It will arrive at 33 time units because of 7 time in between. So, then when it comes at 33, it is not, because it already sees one other person, C4 has also joined the queue, and then C3 will also join the queue, and its service can only start little later down the road. We do not know when it will be, but now that it reaches 33, now what happens is the system clock, if you look into it, this was 20, then it was 25, then this was 26, this is 34, still 33. So, then the next event that will come out of this is the 33, because the simulation clocks jump from. So, the first the clock will start at 8, it will jump to 8 and 14, then after that 14 it will jump to 15, from 15 it will jump, it is not supposed to jump to 25, it will jump to 20, and once it jumps to 20, then it will jump to 25, 25 it will get service started, then it is supposed to go to, not instead of 34 it will go to 26, and it scheduled the service at 34. Then instead of this, it sampled the next one and it got the time as 33. 33 it will schedule the next arrival. Let us say we took the time of 10. So, it will become 43 time units. Okay. Then the next time that will come out of it will be 34, and 34 is the service beginning of the fourth entity, and you sample a time, and let us say we get the time value as 5. So, we get it as 39, and the entity will leave at 39 time units. Then we look at the time period, because 33 is over, then before 43 there is 39, it comes in and the 33 entity will start its service at 39, because it is already waiting in the queue, and then we sample a value, because this is the next biggest time, we take the time as let us say 8 time units, so that will become, 8 is fine. So, that is 47. It will be over at 47, and the entity will leave at 47. Then we look at 43. At 43, what happens is this entity has arrived, but it is still waiting in the queue. So, we will trigger the next arrival. We take a time of another 15 minutes or let us say 12 minutes, let us say. So, 43 plus then 53. So, at 55 the next entity will arrive. Then the time will go to 47, because at 47 this can begin the service, and let us say we took the time of for the time of let us say 6 time units or 7 time units. So, it will become 54 like this, and the entity that comes in 55 will immediately start the service at 55 like this, and then the time will continue. Let us say we sample a time of 5 and it becomes 60, and this and then this will trigger the next arrival like this. So, let us say we cut the simulation exactly right here at the 7, that is a stopping condition. As soon as 7 entities are over, we are done with this. Okay. So, in this case of the entity, you can say that server busy, wait for service. Here also you can see that server busy. Here also you can say that server busy. Here also server busy. The last case it is server idle. Okay. So, if you want to calculate the time between arrivals, okay, I am going to see whether I can erase this without making a mess. So, let me do this properly, only up to this much. Okay. This also. So, the time between arrivals TBA1, that is equal to 8 minus 0, that is 8. TBA2, time between arrivals, that is 15 minus 8. So, that will be 2, 7. TBA3, time between arrival 3, that will be 20 minus 15, that is 5. TBA4, time between arrival 4 will be 26 minus 20, that is 6. Time between arrival 5, TBA5 will be 33 minus 26. So, that is 4, 7. So, TBA6 will be 43 minus 33, which will be 10. TBA7 will be 55 minus 43. So, that will be 12. So, like this. So, this is the time between arrivals, individual time between arrivals. So, you have 7 entities that are come in. So, if you sum this up, okay, that will be 7 plus 2 9 plus 6 15, 15 plus 5 20, 28, 30, 35. So, 3, 1, 2, 3 plus 2 5, 55. So, 55 was the sigma sum total of the time. So, average TBA will be 55 by the 7 entities that has arrived. So, it is about 7 point something, right, 7.9 or something like that. So, on an average in this end you can see